Sublimation. Sublimation is a purification technique for solids and organic compounds with lower melting points. Sublimation is the process of a solid becoming a gas. Sublimation becomes a gas without going through the liquid phase. Sublimation is one of the three forms of phase changes that acts exothermically. Some examples of sublimation include dry ice and freezer-burned products. Dry ice is the solid form of CO2. Originally, carbon dioxide is a gas at room temperature, but is able to sublime and go directly into the solid phase. Freezer burn occurs when vibrating water molecules rise to the surface and evaporate, causing food to be damaged by oxidation. Moisture from the outer layers of food sublime in the freezer air, which is why there is a formation of crystals. The types of phase changes include gas, liquid, and solid phase changes. Attached is a phase diagram. Between the solid and liquid phases, melting and freezing occur, as well as sublimation. There is also an increase of intermolecular forces and an increase in enthalpy of the system. Between the liquid and gas phases, vaporization and condensation occur here, also having an increase in enthalpy of the system. How does it work? Sublimation occurs when a compound's vapor pressure is equal to its applied pressure. Sublimation requires a reduced pressure, which most solids do not readily have. Sublimation requires reduced pressure because reducing the pressure of the system allows for solids to boil at a lower temperature. Sublimation also occurs when a substance absorbs endothermic energy from its surroundings so quickly that melting never actually occurs. Compounds that sublime tend to have weak intermolecular forces. It is most common to use vacuum sublimation when attempting to sublime volatile substances, since some substances will char or decompose if heated under standard atmospheric pressures. Step 1. Place the dry solid at the bottom of the apparatus. If the solid is chunky, crush with the mortar and pestle. If the solid is wet, condensation may form during sublimation, which may cause crystals to wash away. Step 2. Secure the apparatus to the ring stand. Step 3. Grease the joint that connects the pieces of glassware. Grease can be applied to the apparatus using a syringe. Step 4. Insert the cold finger and twist the two glassware pieces together. Step 5. Connect the apparatus to a vacuum source and begin vacuum filtration. Keep in mind that there should be no hissing sound heard from the apparatus. If you do hear a hissing sound, check the system for any leaks. Step 6. Prepare the cold finger. If you're using an empty tube, fill the cold finger to the top with ice, then pour about 3/4 of the tube with water. Also, be sure to begin vacuum filtration before cooling the finger. This prevents any condensation from forming and potentially washing away any new forming crystals. Step 7. Heat the solid on a hot plate or Bunsen burner. Increase the rate of heating reaction if the reaction does not begin within a few minutes. In this example that's presented, they are heating the apparatus with a heat gun, but for our lab, it is more practical to use a Bunsen burner or hot plate. Step 8. Once the solid has been deposited onto the cold finger, continue sublimation until all of the volatile substance is transferred. If the solid begins to deposit on the outsides of the glassware, wave the Bunsen burner up the sides of the glass to coax it away. Step 9. Remove the coolant from the cold finger and allow for the system to reach room temperature. Step 10. Reinstate air pressure to the apparatus. And step 11. Remove the cold finger and gently scrape the crystals into a beaker or a watch glass. Once your crystals are onto the watch glass or inside of the beaker, you can place this inside of your drawer and keep it until the next lab. These are my references. Thank you.